Okay, this video is just going to go through these properties, the algebraic properties, which we will be needing a lot this unit and in future units for our proofs. And so as we click through those, just please make sure that you're paying attention and not just copying down, but listening to the explanations of what these things mean so you'll be able to identify them in the future. So this first example, if A equals B, then A plus C equals B plus C. If you notice, all they're doing is adding the same thing to both sides, or A minus C equals B minus C. This time they're just subtracting the same thing from both sides. Either way, it's called the addition property, because technically when you're subtracting, you're like adding a negative. So it's just the whole thing, whether you're adding or subtracting, is called the addition property. The next one, we are multiplying both sides by C, or dividing both sides by C, as long as C isn't 0, because you can't divide by 0. So multiplying or dividing is called the multiplication property. So this could be used when, like, you're simplifying something. So you have 4x equals 12. When you divide both sides by 4, that would be an example of the multiplication property. For the addition property, if you had 4x minus 3 equals 11, when you add 3 to both sides to cancel off the 3, that would be the addition property. The next one, A equals A, or line segment AB equals line segment AB, or angle A equals angle A. This one's going to come up when you have two sides, or you have the same side being used for two different figures. For example, if two triangles are right next to each other and they share a side, we're going to have to be proving that those sides are congruent. Well, obviously, if it's the same side, it's congruent, but you still have to prove it. So that's called the reflexive property if you're going to be using the same thing twice or for two different figures. The next one, if A equals B, then B equals A. Or if one line segment equals another, you switch around, it's still the same thing. This is called the symmetric property. So it doesn't matter which one you put first. The next one we use a lot. So if A equals B and B equals C, then A equals C. If you have two line segments that equal each other, A, B, and CD, that are congruent to each other, but then CD is also congruent to another segment, then AB is congruent to EF. The same for angles. A is congruent to B and B is congruent to C, then A is congruent to C. This is the transitive property. We're going to use this one a lot. The next one, if A equals B, then B can replace A. We use that a lot too. It's called the substitution property. And then this last one, distributive. You distribute the A to everything inside the parentheses. So you end up multiplying A times B and A times C. That's the distributive. You've seen that before. And then a couple extra ones. A plus B equals B plus A. That's the commutative property for addition. You can add them in either order. You can also multiply in either order. That's the commutative property for multiplication. And then if you have three things you're adding or multiplying, you can do those in any order as well. And those are associative properties for addition and for multiplication. So moving forward, I would like for you to try these on your own. So I would like you to pause the video, try to figure out what these are, use the examples for the notes up at the top, and try and decide what each of these are. All right, let's see how you did. This first example, AB equals AB, when it's the exact same thing that you're saying is equal to itself, that's reflexive. If the measure of angle B is 30, then half the measure of angle B is 15. So we replace angle B with 30. So we substituted this 30 into this angle B because we know that that's equal to it to get 15. But as I'm saying that, I'm looking and I can see how this could also be multiplication property, because if I take half of this side and I have to multiply it by half of this side, so half of this angle would have to be half of 30, so that would be 15. So I can see it multiplication too. So remember that in geometry you can do things a couple different ways and still be right. So it's something very important I need you to remember the next few weeks, because there's things that I might think of it one way, but you might think of it another way, and that doesn't mean that you're wrong. You might have to explain it to me of why you thought that, but it doesn't mean that you're wrong. So we're going to have to be kind of learning together. The next one, if angle A is 40 and A equals B, then angle B is 40. Transitive property. This is kind of that the same thing equals two other things. So those two other things are also equal. All right, then number 4, reflexive. So we have angle A is congruent to angle A. The difference between reflexive and symmetric is reflexive is you're literally talking about the exact same thing being congruent to itself. Symmetric, you're talking about two things being congruent and realizing that you could flip it and they'd still be congruent. So because this is the A and the A, it's just reflexive. And then number 5, we are adding these two together first and then that one, or we're adding the last two together first and then the first one. Same thing. It's called the associative property of addition. And then the last one, the commutative property of multiplication. I can multiply z times y or flip those y times z, and it doesn't matter. So that's the commutative property of multiplication. So that is it for these notes. The next thing that you're going to do, if you have not been in the hallway, you'll go to the hallway at some point, but there's also a list of about 16 of these that you're going to practice on notebook paper. So on the back of whatever you're working on in the hallway, you're just going to number it 1 to 16 and you're identifying these properties. Like I said, maybe there's more than one answer. Maybe there's more than one property. Maybe you're looking at it a different way than your neighbor. So have those conversations and talk about it.